Hi everyone, I just wanted to make a quick video to recap some of the things we discussed in class today. So we'll start by taking a look at the graph that's on the screen, and we want to look at this graph and determine where this function is increasing, decreasing, and or constant. Okay, first let's talk about what we're looking at. So we're trying to determine where this function is having any type of behavior. We are looking or concerned about the input values, the x values. So we want to determine where this function is increasing. Remember, when we look at graphs, we read them from left to right, just like we would read a book, okay? So if I want to determine where this function is increasing, I'm looking for where the function is going up, all right, or increasing in its output values. So I'm looking for the values of x that would make this function increase for y. All right, so if I come right here, we can see that this function starts going up from left to right here. What is the value of x where the function begins to increase? This value on the x-axis is a positive 4. So this function is increasing from positive 4 to positive infinity. Remember, when we are discussing whether the functions are increasing, decreasing, or constant, we are discussing it on an open interval based on what the authors of your textbook say. So be sure to select the interval that has parentheses because, again, we are discussing increasing, decreasing, and constant over open intervals. All right, let's look at the same function and discuss where it is decreasing. Remember, we're reading from left to right, just like these are words. So if our graph is read from left to right, if I trace along the graph, it is going down on this interval. What values of x does the graph go down on the interval? And it goes down beginning at negative infinity because this arrow indicates that the graph is continuing to go towards the negative infinity direction. So the graph is decreasing from negative infinity to negative 4. Again, use parentheses when writing this interval. Lastly, where's the function constant? This function doesn't increase or decrease. It's a straight horizontal line along this interval. So the function is constant from negative 4 to positive 4. Again, use parentheses because we're discussing it over an open interval. The next topic that I'd like to review with you is domain and range. Remember, domain is the set of ordered pairs that consists of the x coordinates. So when we're discussing domain, we are looking at the x coordinates, the input values. All right, if we're looking at a graph, we're going to analyze what's taking place along the x-axis. If we're talking about range, we are concerned about the output values or the set of y coordinates. So if we're looking at the graph, we're going to look along the y-axis. Let's look quickly at a few examples. If we go back to the example that we just took a look at, and we look at this graph, let's talk about its domain. What types of values are we allowed to input? What types of values exist on the graph with regard to the x coordinates? So I'm going to trace along the graph, all right? And I'm moving across horizontally because I'm talking about the x values. What kind of x values can we put in? Can we put in negative x values? And if I do that, do I have any holes in my graph or any gaps? Can I put in 0x or 0 for the x's? What about the positives? So we'll notice that the domain of this function is negative infinity all the way to positive infinity, enclosed in parentheses. Let's talk about the range. Range is concerned about the y values. What types of y values do we get out? A lot of times it's easier for students to kind of think about this in terms of ordered pairs. So if I were to say what ordered pair exists here, what is this ordered pair where I have the arrow? This ordered pair is You're absolutely correct. We go over 0 and we go up 2. So this ordered pair is 0, 2. All right? So what you'll notice is the smallest y value we can get out of this function is a positive 2. The largest y value that we can get out if we were to list like all the ordered pairs that exist along this blue graph, you'd notice that it would be positive infinity. So the range for this graph is positive 2 to positive infinity. Again, to reiterate that point, there's nothing on the graph in the negative region of y, all right? And again, the smallest y value that we get out based on the x would be a positive 2. If we were to write that in interval notation, we would enclose that 2 in a bracket, okay? Because the graph actually, the range, of the graph actually exists there at the 2. So let's discuss the domain and range of this graph. This graph represents the function the square root of x plus 2. If we want to find the domain, we are concerned with what types of values can we input for x. So again, if we look across the x-axis, we see that when we begin putting in values of negative 2 all the way increasing to positive infinity, we get a picture out. Our graph exists. That means that the domain of this function is negative 2 to positive infinity. All right, we can determine this algebraically. Remember, we have the square root, and we cannot take the square root of negative numbers and get out real numbers, okay? So we want to find out when what's underneath the radical, which is called the radicand, when it remains or where it remains positive. We want what's underneath our radical sign to always be positive. We want it to be greater than or equal to 0, okay? That way we won't run into any imaginary numbers. If we solve this algebraically, we would subtract 2 from both sides, and we would find that x is bigger than or equal to negative 2. How do we write this in interval notation? Because we have an equal to bar, we know we would have a bracket, negative 2, comma, positive infinity. In case this is still kind of a little fuzzy, let's look at what this inequality would look like if we were to graph it, okay? You don't have to do this, but I just want to show you for demonstration purposes. If we wanted to graph this inequality, x is greater than or equal to negative 2. I would make a kind of really sketchy looking number line, okay? And remember from your DMA classes or from your other math classes that when we have the equal to included in our inequality, that means that that number is actually included. We would have a closed circle or a dot, negative 2. And I like to tell my students to use the inequality symbol as an arrowhead to tell you which direction the inequality goes or which direction the graph of it goes. So it goes this way. Okay? All these pieces are related. Again, our domain is negative 2 to positive infinity. Lastly, let's look at the range of this function. Again, remember with range, we are concerned with the values that we get out. We're concerned with the graph, and we're looking at what happens along the y-axis. What kind of values do we get out of the function? Okay, let's just do some investigating really quickly. If we were to, let's say, make a table of values, all right, and your calculator will do this for you, but if we were to make a table of values, okay, using this function, let's say I let my x be negative 3. If I substitute in a negative 3 for the x, I would take the square root of negative 3 plus 2, which would be the square root of negative 1, which would give me an error, okay, because we are only working with real numbers. So in the table of your calculator, you'll see an error. That error symbol should alert you to, hey, we can't have this, all right, or a type of restriction in the domain and range, all right? If we substitute in -2 for x, we would have the square root of -2 plus 2, which is the square root of 0, which is 0. If we were to substitute in -1, all right, I'm not going to write this out, but if we were to substitute in -1, we would get the square root of 1, which would be 1. If we were to substitute in 0, we would get out the square root of 2. So if you notice the output values, what we're getting out for y is 0, and it keeps going to positive infinity. All right, so that indicates what our range is. Let's look at the graph. We notice that the picture of our graph actually exists where on the output, in terms of output. It exists when y is 0 or bigger. There's nothing in my graph down here on the negative part of the y-axis. So the range for this function is 0 to positive infinity, and the 0 is included. Please let me know if you have any other questions.